absolute value inequalities, and we're going to talk about ones involving less than for now to start with. When solving absolute value inequalities, there are two cases to consider. Case one, the expression inside the absolute value symbols is non-negative. Or case two, the expression inside the absolute value symbols is negative. So we've looked at absolute value equations before, and we've talked about the fact that the absolute value is talking about the distance from some midpoint. So here is our midpoint, and here is how far our variable could possibly be from that midpoint. And we've talked about equals to, where the distance was exactly that amount. Here we're going to talk about inequalities, where we could talk about the distance being less than this 12, but it could also be a negative. It could be a negative out here. We talked about that negative when we talked about equations also. And what we did with our absolute value equations is we split it up into two. One where our distance was positive and one where our distance was negative. We're going to do the same thing here with inequalities, only there's one other piece that we have to consider. We have to consider that inequality here. So when we split this up, we're going to consider two possible pieces here. We're going to consider that the distance is less than, this original here was less than or equal to, my original equation, inequality was absolute value of a minus 3 is less than or equal to 12. So it might be true that this distance is actually less than 12, less than or equal to 12. Or what might be true is that this distance is actually greater than or equal to negative 12. So we're actually making two switches here. We're not just only changing the sign of our distance, we're also changing that inequality sign. Remember when we talked about when we change that inequality sign when we change both sides to their opposite. And that's really what we're doing here. We're saying, well, this could be its opposite. Well, that means this could be its opposite also. So we're changing everything to its opposite. So when we start with an absolute value inequality, we want to make sure a couple of things. We want to make sure the absolute value symbols are by themselves on one side. And then when we split it up, immediately we lose our absolute value symbols. We're going to use the version that we've got in our original here. So here we're just going to use exactly the less than or equal to 12, the same as it is in the original. And then we're also going to use what's inside our absolute value symbols, but we're going to change the inequality and change the sign of what's on the other side. So here we're going to change this to greater than or equal to, and our 12 will become a negative 12. Now from here, it's our compound inequalities, which we've been working with. So from here, we've just taken this and changed it into a compound inequality. So we're going to work with this like a compound inequality from here. So here I solve each of these inequalities. Notice when we've been talking about our compound inequalities, we've been talking about and, we've also been talking about or. So notice I haven't put and or here yet. I haven't really figured out which one that is yet, so I'm going to leave that until I get to the graph and figure out what the graph tells me, and then just go backwards and decide whether this is and or. So here I come up with a is less than or equal to 15, and a is greater than or equal to negative 9. So I'm going to go to my number line, and I know these are my boundaries. I'm splitting up my number line into three parts here, so I end up with numbers that are less than negative 9, numbers that are in between negative 9 and 15, and numbers that are larger than 15. I've done solid dots here because these are both equal to. All right, so I've kind of split that up. And now I'm going to do a check. Since I've divided my number line into three parts, I'm going to pick a number from each part, a friendly one that's easy to work with in the original. Now I'm going back to the original, and I'm going to check each one. So here I picked negative 10. I plug negative 10 in. Negative 10 does not work in my original inequality. So I know that the numbers less than negative 9 here are not going to be part of my solution set. Next, I'm going to pick a number that's in the middle. I'm going to choose 0. So I take a look at my 0, and yes, that totally does work. So now I know that the numbers in between negative 9 and 15 work. So I'm going to fill in this part of the number line here. And then I'm going to try a number that's larger than 15, because I could have this number line, I could have this graph of this with an arrow going to the right. I don't know if I'm including two of these parts or not. So I'm going to try a number larger than that. I picked 20 to try. When I tried 20, that does not work. So I know that the graph of the solution set for this absolute value inequality is between negative 9 and 15 inclusive. I'm including like negative 9 and 15. And I know that when I look at this number line, this is a number line for an and. This is an intersection of two. So this is an intersection of a is less than or equal to 15 and an intersection of a is greater than or equal to negative 9. So it's an intersection of the two, which means this is an and. So I'm going to finish up by writing the solution set to this, and we're going to do A such that, and I'm going to start with my negative 9. Negative 9 is less than, we used A here, or less than or equal to, A, which is less than or equal to my 15. When I'm writing this, my set notation here, start with the negative 9, your A is in the middle here, and my 15 is on the end. So there is the solution set in set notation to my absolute value inequality, and here is the graph of those solutions. All right, let's take a look at a couple more, including a word problem. Solve b plus 6 is less than, the absolute value of b plus 6 is less than negative 8. So again, I'm going to split this up into two. I have my b plus 6 is less than negative 8 just the way it is. I just took out the absolute value symbols. And then I'm going to take out the absolute value symbols, but I'm going to switch the inequality, and I'm going to change the sign of the expression on the other side here. So here I end up with positive 8. I'm going to solve each of those two. I end up with b is less than negative 14. I also end up with b is greater than 2. Again, notice I haven't written and or here because I don't really know whether this is an and or an or yet. There is a pattern that we'll come across eventually, but for right now I just want you to kind of look at how the pieces play out. So I've got my negative 14, which is here. If I graph that, it would go to the left. I have my b is greater than 2. If I graph that, that would go to the right. I'm doing open circles because these are not equal to. So now I'm going to check three parts. I'm going to check negative 20 over here on the left. That doesn't work. I'm going to check a 0 in the middle. That doesn't work either. And then I'm going to check a 10 over here on the right, and that doesn't work. So none of these actually work. So my number line now is empty. I end up with the empty set, which means that we have no solution, which is kind of crazy. So let's go back and look at the original here. This is telling me that the absolute value, and remember an absolute value is always a positive number, or it's a non-negative anyway, so it might be 0, but it's going to be positive, is less than negative 8. So what this original absolute value inequality is saying is that a positive or a non-negative number will be less than a negative number. That can never be true. I will never come up with a non-negative number less than a negative 8. So it makes sense that there's no solution to this. It makes sense that there's no number that will actually make this work. So we have a no solution for this particular one. So you can end up with some kind of weird, crazy solutions for this. We could end up with none of the number line working. We could end up with all of the number line working. We could end up with 2 sections or 1 section. So we want to take a look at that number line and see what makes sense. Last one we'll look at a word problem. The average annual rainfall in California for the last 100 years is 23 inches. However, the rainfall can differ by 10 inches from the 100-year average. What is the range of annual rainfall for California? All right, so I'm going to define my variable. R is going to equal the rainfall in inches. Now, if you remember how we write out an absolute value equation, we've got our absolute value, and we're taking our variable, and we're finding the distance from the midpoint. We want the midpoint of that. Where's the middle? Where's kind of our goal amount that we're kind of aiming at? And that's going to be equal to the distance away from the midpoint. Now here we're going to write an inequality, but I've just kind of set this up to give me the basic pattern. So my R, my rainfall, now it says that the average rainfall is 23 inches. So that's kind of my middle. That's kind of where I'm aiming for. It's on one side or the other from 23. But the average, right in the middle, is 23. So I'm going to subtract 23. I know that the difference, it says it differs by 10, so I'm going to put my 10 on the other side. And now I've got to figure out what to do in the middle here. Well, it says it differs by 10 inches. It's not more than 10 inches. It could be 10 inches or it could be less than 10 inches. So the distance is going to be less than or equal to my 10. From here, we're going to solve. We're going to split it up into r minus 23 is less than or equal to 10. We're also going to split up into r minus 23 is greater than or equal to negative 10. And then we're going to solve. So I come up with the rainfall could be at the least at the, oops, do I have mine? No, that's right. R is less than or equal to 33. At the most, it's 33. And R is greater than or equal to 13. So at the least, it's 13. So the rainfall is from 13 to 33 inches. It's anywhere in there. So again, remembering this kind of pattern that we come up with for our absolute value equations, we're going to apply this to inequalities also. This is just a basic format for writing an absolute value inequality. So again, the big point here with the absolute value inequalities, Remember that we're going to split it up into two parts. One, pretty much straightforward the way it is, and the other, we're going to switch the inequality sign and change the sign of the expression on the other side, remembering that our absolute value symbols have to be by themselves at this point in order to do that.